I hope that some of the kids that in the factory I met in the real case that some people give the groove position, or groove is the number of the groove larger than 1. They want to give this joint bearing have a good lubrication, so they put a lot of the entrance of the oil in somewhere here. Okay. Around this whole the sleeve. Okay. You just put more than one of the groove, 然后把它放了更多的这个 groove around this sleeve. It's wrong. Okay. Okay. You put all a lot of the groove around this 330 degree. It's wrong design. Okay, wrong design. Because you put the sum of the hole in here. Originally, they have the positive pressure. But you put this hole in here or groove in here, you'll find no positive pressure. Okay. They just think very simply that I give you the oil, you can give me the good lubrication. I will say wrong. I will say wrong. Okay. Your lubrication, the final purpose is just to create the positive pressure to support your externally applied load. 你的目的是要把产生正压，并不是要供油，供油它进不去的，没有用。Okay, so lubrication is not simple, not so simple. Before about 40 years ago, I started university in Taiwan. Everybody say lubrication just put oil in your machine. Is correct? Wrong. You know the machine product value in Taiwan in the modern time is the first rank around the world. Okay? But high precision machine, most of the high precision machine, they are the product of either the Japan, German, or United States. So value is large, productive value is large, but it's not in the high rank. This is the big problem in our Taiwan. So everybody have the duty to improve the precision of the Taiwan. Like the TSMC, the semiconductor, it is famous around the world. You can do it. Okay. So you have to take the lubrication course. Try to improve the high performance bearing in the robot, in everything, all the machine, in one machining. Okay, that's very important. Okay, so you have to determine the position of this load first. Then you can determine your attitude angle. Then you can determine the direction of your center line. In this case, if you know the position of your center line, congratulations, you just put your hole or groove very near this line. Okay, I give you the explanation. If you delay this entrance to be the large angle, for example, this put here, you'll find that your positive pressure also, move, and your magnitude has been reduced. So you have your, put your entrance to be in the early position, allow in the convergent region, they have some point, you can create the maximum particle pressure. 所以你要尽可能的把你的这个进口放得远离一点，远离这个正压可以产生的区域。你把这些孔放得越后面，它的压力怎么样？就掉下来了。它该发生的就是 like you grow up when you are young, when you are young child, but you you short of the nourished food, so your body becomes small. Even at the age, you have to grow up faster, but you just short of the nourished food. Okay. So in this case, you put your position in the entrance. It's a very, very key issue. Okay. And then you don't need to put additional entrance. That's the wrong way. 你不要再放了一个就够了 ，OK， 知道吗？要让这个沿着都在做。They have argued in the factory. I mean this kind of the situation, this kind of circumstance, a lot of case, a lot of the case in the factory. They argue each other. Each department say this is not my role. This is your design. Finally, you will find that the design is wrong. Okay. So everybody have a duty, and also everybody have no duty. Okay, because your design is wrong. Okay, this is a big problem. Okay, all right. So there's we'll talk about here. Now, the friction coefficient. Okay, if you sell some of your product to some people, they will ask you, what's the efficiency of your machine? Of course, we hope that the friction coefficient is small as possible as you can. Okay, should be the low. Okay, so the friction is used to identify your efficiency of your machine or any kind of the machining. Okay, and then total and the side flow. Just talk about it. This the Q is the flow rate pump into the convergent region. It's just the sum of the QB, and then you are newly supplied due to you have the side leakage. You have side leakage, so flow back QB is smaller than your Q supplied to the convergent area. So you need a pump to supply additional QS value. Okay, so we have the Q and the QS. Okay, QS is supplied by the pump. Actually, it is equivalent to, it is equal to the side leakage flow rate. Okay. Then, because you side leakage, you cannot return, so you have to additional put it into this QS by the pump. Okay, 你要用 pump 来提供这个额外的这个流量，因为它也跑掉了。Okay. Angle maximum ratio. Let me check it. Here's the ratio profile. Then they have a maximum ratio. Okay. Now, this maximum ratio they have the angle. This angle we call the phi m. This phi m, it is zero angle. It's not from here, not from here. It's from here. Okay, it's from here, from the load. Okay, this is load direction, right? And then you have the maxima is this angle. So we have the phi m is not is different from this phi. 我们定义这个 phi 角是从这一个最大有某度的地方，但是它定义这个 phi 角在指的是最大压力的，是从这个 load 的 angle 跟到最大压力的地方。So the phi m, the angle defined for the phi m is different from the phi. Phi is from the maximum fin thickness. Here is defined from the load direction and then the maximum pressure. The angle between these two parameters. So this is different, all right? So you're based on this one. Another phi naught. First phi naught is this angle. It means the terminating point or terminating position of your particle pressure. 你正压的终止的位置。How to determine it? I have told you that you use the Reynolds boundary condition to determine it by the computer. 使用这个电脑 use the numerical method to determine the terminal point of the particle ratio. Okay, by the Reynolds boundary condition, by using the Reynolds boundary condition. 所以你使用 Reynolds boundary condition 来决定压力终止的地方。You will find the pressure in some of the in the convergent region. In the convergent, this is convergent region from here to here is convergent region, and then it is this particle pressure is tended somewhere after the convergent region and then into the divergent region. 我们大部分的正压 most of the particle pressure are created in the convergent region, but there is still a small portion of the particle pressure they are extended to the divergent region. 这个区域就是 divergent region， 知道吧 ？OK， 所以压力它大概是这样。OK，not the whole journal vary. No, this is small portion. OK，so how to optimize this particle pressure？ 你怎么样让它得到最好的一个设计 ？This is our technology, our knowledge to use to obtain the optimal design. Why you take this course? Not just for the grade. If you take this just for the score, for the grade, I hope that you dropped it. It doesn't make any sense. You need it to in your design, in your business. If you are boss, you ask me to help you, I will say you how to help it by yourself. Okay. You do help by yourself. Okay. You have to have this knowledge to help you to have the optimal design. All right. Okay. So this is very important. My ex thought you work in the Tesla in San Francisco. 我老大现在就在 Tesla. One of the item in the chain rule, chain supply, 在一个供应链里面，一个很重要的 lubricant. So now she is responsible for one item of the her business, just lubricant. How to obtain the lubricant in the electric vehicle, electric car? Okay. Different component use different kind of the oil. They have a controlling oil. They have a different area use different lubricant property. So they have to control the lubricant supply. Okay. So everything. She didn't take any lubrication knowledge, but she gave me the call frequently that he asked me some of the detail in lubricant. So everything you do it, nobody can guarantee that you cannot use it anymore. Someday, maybe you just have to use this knowledge, but you short it. You short out. 你如果缺了，你在工作上你就很辛苦。Okay, so that is my past experience that you take any course, keep in mind, just for your business, for your money, for your future. Okay. So this we continue, right? Here, final is location of terminal pressure. So this is determined by the Reynolds boundary condition. And then there's very important things that temperature rise. The lubricant into the area, they have a shear force. They have a shear force, so they have created the friction force. Shear stress created the friction force. This friction force allows this kinetic force or dynamic force change it to be the friction force. This friction force is created in terms of the internal energy increase. As the internal energy increase, just rise your temperature. So temperature rise is due to you have a lot of friction force created in every flare of the lubrication area. Okay. So in this case, what temperature rise? How do you evaluate it? If your machine have a high temperature rise, I guarantee that your machine cannot work with long time. OK， 你的这个油温在任何工厂里面，它在操作的时候都有个允许的一个温度。The allowed temperature in every factory, they have a limit value. If you overpass or exceed this value, it means that your machine have a trouble, have a problem. Okay, so the temperature rise is also very important factor in our case. All right, here, TI, what is TI? TI is just we have the oil supply here, right? So they have the Q back, and then they have a QS supply, all right? These two oil, they have a different temperature, but they are mixed together to get a new temperature. This new temperature we call the QTI. TI is just corresponding to the Q. The Q is just the flow pump into the conversion area. Is so that the temperature TI is just corresponding to your Q value. Okay, your Q flow rate. All right. So you have TI, and then you have the delta Tm. The delta Tm will show in that they have an expression. 还有一个数学式子 they have one formula to determine the delta Tm for your journal value. For your journal value. Okay, so why we have 1/2? The 1/2 is a factor used to because oil from here then return to the back, the original position. Every phase, the temperature is different. The shear stress every phase is different. Of course, the temperature every phase is different. So in this case, we consider that your temperature is different. The temperature is different than your viscosity, oil viscosity. Our oil viscosity is strongly affected by our temperature. 我们的油的粘度对油温的这一个影响非常敏感。So your temperature from the inlet to the every phase, we find that the temperature also different, right? The temperature is different. Your viscosity every phase also different. So in this case, we give it a simple calculation, simple, make some of a simplification to give the temperature rise. Okay? So in this case, we have the 1/2. 所以 1/2 就是除以2的一个原因，事实上不是一个很正确的解。It is not an exact solution. We just give the approximate solution to the temperature rise from the convergent area to the divergent area, because every phase the temperature is different. 所以我们每一个地方温度不一样，我们就大约的去算。So they have a 1/2 factor here, just because they have this reason. OK, 然后这个原因，好，我们才给了1/2。So if we can determine the delta Tm, that's a very key issue we have to do. Alright, after determine this one, then your temperature, every phase can be determined. Okay, alright. So this Tm is used to determine your viscosity and then your density. 这个温度是用来去决定 in the Reynolds equation, they have the viscosity. The viscosity, not the original viscosity, because you have a temperature rise. So the temperature rise, the final temperature become this value. Use this temperature to obtain your viscosity in the Reynolds equation. 我们在Reynolds方程式里面的一个粘度，就是靠这个 delta Tm 来得到的。OK。不动了，天哪！ Okay, so use the computer, use the numerical method to solve it. The following section showing some of the results for the final length journal value. 我们把所有结果 showing 在这个下面几节 ，OK。And here in Figure 12.2, they have two ordinate. One ordinate is the mean fin, the fin thickness, minimum value, minimum fin thickness, or the clearance. Okay, this is a dimensionless, 无因次的。Here, eccentricity ratio also dimensionless, 它也是无因次的。Then here, we call the WR. Give the exponent to be the -1, so it's proportion to inverse proportion to the W. Okay, so in this case, keep in mind. Let us look at this. For this value, we give the mark small rho. 这个地方是小负荷的时候，把它记一下。Here. Other left hand, this is large rho, high rho. 这是低负载，高负载。OK, alright. And then 我们有两个纵轴。One is the fin thickness. Why we need the H minimum? Why we need this one? Anybody can give me the answer? Very important. Your design. What is the minimum fin thickness? Keep in mind, give the remark is very important. All the parts are assumed that your surface are very smooth. 你的面你是假设是完全光滑的面 ，but in the practice， 在实际的一个场合 ，you cannot prepare your surface without the surface roughness. It's impossible. So, if your fin thickness, for example, your surface minimum fin thickness is here. This is obtained for smooth surface. But in real case, your surface have a roughness. You find that your lubrication behavior are much affected by the surface roughness. But you evaluate it based on smooth surface. 你计算它的时候是假设它是一个平滑的面，但是 in real case, your surface no longer to be the smooth surface. They have a roughness. So two surfaces have roughness and then they have the interaction. This interaction of surface roughness will cause a large influence on your lubrication behavior. 所以你表面如果有粗糙度的时候，这个粗糙度就跑上来了。So in this case, H should be sufficient large. But if too large, your load will down. Okay. So you have optimal design. The first one, you have to consider the surface roughness. But you cannot have your minimum fin thickness too large value. Because your fin thickness is too large, you will find your value, have your load capacity to be reduced. Okay. 所以这个最小油膜的这个设计 in our case is this one. And then here is statistic. Okay? Alright? Okay. This one essentially equal to 0, meaning small rho, because they are concentric case, mean the center of the sliver, the center of the journal are at the same point. So no eccentricity. 所以这个没有负载，这个是大负载。Okay, alright. Now, lambda k for this one, round 0, they just show the numerical solution. for 4 cases. For the gel, what is gel? Keep in mind, this lambda k equal to gel is mean the infinite long. 很长很长轴承，长轴承 ，OK。然后呢 ，we have a lambda k change it to 4. This 4 case is a short bearing, but not infinite short. It's a short bearing. It means from the infinite long to reduce your bearing length to be small and small. OK， 所以这是很长的轴承。然后你的轴承变得越来越短 ，OK， 但是不会太短，不会太短 ，OK。好了，so we'll turn to the solution look like this one. Now we have a design of the bearing. There's a lot of questions they propose to me or show me. I will say that you have your design for what is the main purpose. 你真实的目的要干什么？ Design they have you design your bearing. They have 2 purposes. One is that your bearing with the small friction coefficient. 如果你的负载要很小的摩擦系数 it means that if your bearing have a small friction coefficient, your motion is very efficient, and a very high precision. 你的运动如果要 with high precision or high efficiency, in this case, you try to have your friction coefficient to be small as possible as you can. Alright. So that's one purpose. Another is that you have a high load. You hope that your bearing can support the high load. So this is based on your load to be large. To be the largest as you can. Okay. You cannot obtain the bearing with the small friction coefficient and the high load. Impossible. Like your hand, they have a 5 fingers. You cannot show all the fingers to be the same length. Okay. So which one is just you need? Alright? So this is this curve is for the maximum load. Okay? For this curve, your friction coefficient is minimum. So in your design, you can in general, you have to choose your load. Load has been determined first, right? You have this load. And then your case, just the second, first your width aspect ratio. You have to choose it. And then you try to have your other property, try to your operating condition in this area. So this area, in the dark area, we call the preferred operating condition, operating area. Okay, prefer 就是我们希望的一个区域。In this area, we cannot obtain the maximum load, but we can obtain some of the friction is sufficiently small. Okay, so this area we call the 我们希望的区域叫 preferred area for our operation. Okay, all right. So you have a load first, and then you have the aspect ratio. Okay, in this case, you try to have your work area inside of this dark area. 你要试着在这个区域来做。So this table is dimensions, so it's a universal purpose, general purpose. 等一下我们会用到。So in the one of example for design of your journal bearing, we can use this chart, this plot. Okay, so this is the first one. Now we continue. This computer is lousy. I hope that everybody, just like this computer, You look like a notebook, very fancy, but the efficiency is not good. Someday in the future, you get the master or PhD degree, it is a master. The key issue is that in your brain or in your mind, how much is inside of it. So there's just very upset for this computer because all the notebook. Okay. All right. Here, for the attitude angle. What is the attitude angle used for? Anybody can answer me? Why you need this attitude angle? I already do many times. You have to use kinematic or dynamic to solve the direction of your load and its magnitude. Then if you know this value, you can determine the center line, right? And your entrance of the pump in flow rate means the groove position or hole position just very near the central line position. So this is useful this one. Okay? If some of people, okay, you didn't attend the class, so you'll find that you're confused. Okay. Because in Taiwan, you will find the tuition is very cheap, okay? Okay. 40 years ago, I studied in the United States, in the Ivy League, okay? The tuition very high, okay? One class, the tuition, just 1 month of the Taiwanese people salary. So we work very hard in there to finish the work. So you have to value all the property, all the class. Okay, don't upset from the class. You learn something for your future, for your country. Everybody just like that. Okay, not just get a degree. How is the degree useful? Wear mask. It's fake. So here, infinite law is short-term. Okay, we can use this chart to obtain the phi angle. Okay, if this direction and magnitude. So here is the low load. This is the high load. Okay, you'll find the high load, very high load. How is the phi angle? Why is that? Very high load. The phi angle is near the zero. In this angle, this phi angle become small, become very small, just close to the center line. Okay? If load is small, then this phi angle, this active angle, become large. Small angle, a small load, large phi angle. Okay. Here, what is it? Oh, RB, mu, C. What is mu? Mu is friction coefficient. Friction coefficient. Okay, 你的摩擦系数. Okay, RBC. There's here. Mu is dimensionless. Mu 本身是无因式的, but you have to take a notice that RB or C is also dimensionless. Okay, mu it itself is the dimensionless. But here we define this one, which is respect to the result. Okay? Here is a load. Okay. You'll find the infinite law 很长的轴承. Your friction coefficient become small. Okay? It's very interesting. Very long. In general, you will think that your friction force will be created because our contact areas become large. But your friction coefficient sometimes is stuck. So friction coefficient, the definition of friction coefficient and the definition of the friction force, they are quite different in the characteristic. Okay, all right? So look at, read it, then keep in mind. Okay. Someday you will be the consultant, you will be the chief engineer, and your subordinate will ask you something, and you cannot answer him. Very confused solution or confused answer. So all the knowledge comes from the reading, the thinking. Okay. My daughter, I have told you that she graduated from the MIT. Okay. She brought the hat for me. Okay. Then you'll find that the front area. What is the word? Not the MIT. Think. Then the side MIT, small. Not like the general head, NCKU, all right? No. Think as the logo of the head. 它的帽子前缘是思考。Are you? Okay. Q, flow rate. Okay. Dimensions. The walk, inverse of walk. Then here. This is no side linkage. This is no side linkage. Because it's very long. Very long, no side linkage. The side linkage can be neglected. The upstream with side linkage. Okay. So in this case, the Q, no, with the no side linkage case, your Q is just small as compared with side linkage. Right. You don't need to, because you don't have a loss in your flow rate inside of the lubrication area. So you don't need the more loop cap or the large loop cap inside of your lubrication area. Okay. But if you have a side linkage, then in this case, your flow rate should be supplied to be a large value. 你如果有个边缺啊，那你要提供给他的油是更多的。If you are both, you hope that the Q is large or small. Which one? You use a large quantity, you need no power. You have to high cost to pump the oil to your system. So hope that the Q should be the small. Because you have the low cost. You wish that you have a low cost. So Q is here. Sorry. Okay. So here, okay, if your length becomes small and small, okay, indicates your quantity become large. Because in the short period, your side leakage become large. 对不对？你的一个损失量就越大，这个时候你就要提供更多的油给他。Okay. All right. So oil control for the pump is also very important. I find that most of the workmen in the factory, they just actively control the oil. I would say that the oil put too much, you have the oil pour, will cause the rotation to be instability, to be unstable. Okay. If the oil is not sufficient large, not enough, in that case, you have the risk of the two surface in contact. 所以油太多、油太少都不好。So keep in mind, control the oil quantity is the first step. You approach the high precision machine, okay, or high precision machining, either machining or in the machine. If we work in the high precision, the forces that control the oil input your lubrication. Then also they have an additional factor will control your precision. But the quantity is one of the important factor you have to do. All right. So this is quantity. Here we have the maximum pressure. This we will find your PN. This is WR, the load. And then your PN. This PN is with the dimension. They have the voltage. Okay. The day after tomorrow. Okay. All right. Then in general, they just work. They work at a high level. They don't any respect any ordinary people. But one day they need your work. You ask me, please give me the. So this kind of job, I never accept. Or I never anticipated that I wanted to be that kind of job. Temporary, not a permanent. Then sometimes it becomes really harmful. Even in general, they wear a mask to be at the high level of the people. This is not your real life. Keep your knowledge. Fill with all the knowledge. You can have your whole life to be happy, to be comfortable. Believe me. Here, PN. This PN is in nominal. 它是在分母。Okay, all right. So here they have a WR. WR is load. WR is load. So for this region, give the mark. It's low pressure region. This is high pressure region. Low pressure region. High pressure region. Okay. 12, 7. I ask a teaching assistant to give you the copy. All right, you have received it? 那个传出去没有？这个是第12章。You have received this chapter material?
On paper?
Yeah. I will ask a teaching assistant to pass for you. You try to, if you didn't, tell me, all right? Because you needed this chapter material, all right? This is low. This is high low. Okay. So you'll find that most of the case, load is high, your pressure. Load is high, your pressure is also high because under this region is a high pressure region. This is a low pressure region. Okay, all right. Keep in mind, your PN is a denominator, not the numerator. All right. So this is maximum pressure and the load. Okay. 많이 있어요. computer is too old. No. 这个帮我调一下。So in the future, you got some of the work. You don't need to use the computer. I think the first thing, use computer to solve it, okay? It will take a long time. You don't need it. The first things, try to get the result has been published or how existed in some of the handbook or in some of the material. Okay. Then next time, and then in the later section, I will show you all the machine we considered at this moment, just assuring this very smooth surface. But in your practical use, in a real case, you have a surface with surface roughness. 你在实际情况是有粗糙度的 ，how to do it? How to improve it? Okay, how to determine the parameter with the more accurate result? Because in real case, you have a surface roughness. So I will give you additional. Those additional material come from where? Come from published paper. Okay. So in the future, you have a design. You can take this material from the handbook or from some of the literature. Another one is that new material from the published paper or from some of the other resource. You can get the result. This result allow you to have your design to be more accurate, 更准确. Okay, so I introduce, not this one. 第10章的，第10章，第12章，这个第12。
就是要第几章
？12章啊。
哦，对吧？
对，没有这个东西。
对吧？12。
对。好，这样了，慢慢下去。好，再上去。前面，OK， 在前面。OK， 好了。OK， 来，第二。Okay, here is the flow rate, right? Here's the side leakage. The side leakage flow rate. It means that you need the pump to supply additional. Here's the QS. QS 是 side leakage， 会流失掉的。也就是说，你要用 pump 去提供给它的。唯一次量。Here is the small load, high load. Okay. So high load, you will find that your quantity is large. With small load, your quantity becomes small. Okay. Alright. 这个是 QS 里面的 side leakage. It is quantity equal to the supply oil you need. Okay. So this is quantity. Here is the PM, all right? Okay. Now, we'll have a 10 minutes break. 5 minutes, okay?